Hello and welcome to this week's video in our course Competition, Policy and Strategy. This week we are going to talk about the solutions to assignment number 9 on the topic of vertical restraints on competition. In the first exercise we are going to talk about the topic investment in services. In order to analyze investment in services, we came up with the following model situation. We are going to consider a market for a homogeneous good on which there is 2 retailers and 1 producer. So we already know that this exercise is going to consider a vertically separated market. So we have downstream and upstream firms. We furthermore assume that on the downstream market we are going to have bare-draw competition or competition through prices. We say that in addition, retailers, so the downstream firms, have the ability to offer service E, some amount of service E. Investing into this service shifts the demand curve upwards. That means for any given price, the demanded quantity will be larger for a positive investment in services E. Technically, this looks, for example, like this. So we have this given demand function, some price as a function of quantity and services E, which reads 41 plus E minus Q. And we can already immediately see that indeed any investment in services will lead to a parallel shift upwards of the demand function. Furthermore, we assume that it holds that the amount of total services in the market E is the sum of the individually offered amount of services of firm 1 and firm 2. Or in other words, E equals E1 plus E2. Then we know that the cost function of the downstream retailers is dependent on this amount of services offered. So the demand function the cost function first has one part that depends on the wholesale price W, so the downstream retailer has to pay the upstream producing firm some amount W for each single quantity it wants to sell in the retail market. This is the first part of the cost function, and then the second part of the cost function is the squared amount of services provided. So we know that with a power of 2, this amount of services is reflected in the cost function of the downstream retailers. So any amount of services provided does, on the one hand, shift the demand function upwards. On the other hand, it increases it increases the costs of the retailing firm by the square of the amount of services provided. Then finally we know variable V, W denotes the linear wholesale price set by the upstream producer, just the way we know it from previous weeks. And then finally we know that on the upstream level, producing this good comes at a cost, at a constant marginal cost of C equal 1. Alright, now we know the whole model setting. And under task A, we are going to consider the situation as is and find the market equilibrium, which in this case not only includes prices, quantities and profits of the firms, but in addition to that, it of course includes finding the equilibrium amount of services provided. Alright. Let's get rid of all of these. So in task A, we are going to show that in equilibrium, none of the retailers will invest in services, which of course implies E equals 0. We are going to interpret this result in the economic terms. We will then calculate profits, consumer surplus and welfare. So characterize the equilibrium. Alright, how can we do this? As we typically do when we are looking at these vertically separated market, where there is a downstream level and an upstream level, we consider the downstream level first. So, and we know that in this particular case, on the downstream level, we have by assumption bare-draw competition. So this means that from the perspective of the retailer, the price in the market, P, is first of all the same for both, so P1 equals P2, and second of all, this price equals the marginal costs. From the viewpoint, or from the point of view of the retailer, of course, the marginal costs is the wholesale price W. All right, so we know immediately simply by considering that this market downstream is assumed to be a bare trend competition on a homogeneous good, we immediately know that the price P1 equals P2 equals the marginal costs, which of course is the wholesale price in this case. So the profit maximization problem downstream now is a whole lot simpler, because previously downstream the retailer had to make two strategic decisions. First, setting the profit maximizing price, and second, setting the profit maximizing amount of services, E. Now we immediately know that the profit maximizing price will be equal to the wholesale price, so in this particular case we don't even have to worry about this anymore. Instead, the profit maximization on the downstream level now only needs to consider the profit maximizing amount of services provided. So what we are technically going to do is we are going to maximize the downstream firm's profits pi I, which are a function, of course, of the wholesale price and the amount of services provided. Wholesale price in this particular case, of course, because this is equal to Pi for both of the firms. And this profit function then reads the revenue, this first half, minus the total costs associated with selling any quantity Qi. So this is the profit function of both of the retailers. It's of course the same for both retailers, so we can simply write it down in the notation with an index I, where I can take value 1 or 2, depending on which of the two retailers we are considering at the moment. But by symmetry, this holds for both firms. And then if we want to find the profit maximizing amount of services, we of course have to start with the first order condition of the profit maximum with regards to this parameter E. So what we are doing is we are calculating the first order derivative of the profit function with respect to the amount of services, EI. If we do so, we immediately notice that this derivative has a negative sign, which of course implies that for any amount E, the profit of this firm is decreasing in E, right? Because this derivative has a negative sign. It's smaller than 0. So what we can see is that for any amount of E, profits are decreasing in E. Logically, profit maximum in this case would be, profit maximizing would be to provide the least amount of services possible. And simply by logic of this exercise, we then come to the solution or come to the result that in equilibrium the profit maximizing amount of E provided is 0, simply because you cannot provide a negative amount of services, of course. Yeah, and the argument is repeated down here because any EI larger than 0 would result in a reduction of profits. And the reason behind all of this, the reason behind this result, the economic reasoning behind this is that the positive external effect is not internalized. Now, what do we mean with a positive external effect? Well, consider that for the shift of the demand function, I'm going to show it to you in a second, the demand function which was defined in the exercise up here, P as a function of Q and E, for this shift in the demand function, it is it does not matter if it's E1 or E2. Both of these investments into services shift the demand function in the same way upwards. And what this means is that if any firm decides to set a positive amount E, or to invest into services any amount, they will shift the demand function outwards, which of course affects both firms. So any investment into services has a positive external effect on the other firm. And this positive external effect is not internalized, which is the economic reasoning behind the result of this exercise, or task A rather, where neither firm has any incentive to provide any amount of services in equilibrium. Right, so now we know the downstream equilibrium. We of course are interested in the market equilibrium, so what we will have to do next is consider the upstream market level. Upstream we have, by construction of this model, a monopolist. So the monopolist maximizes their profits by choosing the profit maximizing quantity. All right, and this of course is the usual profit, the usual profit function that we always consider. It reads price minus marginal costs, so the margin overall, the price cost margin, in brackets, multiplied with the quantity sold. Usually, of course, the upstream monopolist, because it's a two-level separated market, would have a profit function which reads W, so the wholesale price minus marginal costs multiplied with Q. But we already know from the profit maximization problem downstream that in this particular case, the wholesale price is equal to the end consumer's price P. So we can at this point simply substitute W for P. And then we arrive at this profit function. And if we now consider if we now find the profit maximizing amount the monopolist puts onto the market, so by stating the first order condition of this profit maximum and then solving for Q, we find out that the profit maximizing quantity in this market is 20. This profit maximizing quantity comes with a wholesale price, which of course in this particular case, because of better competition downstream, is the same as the end consumer's price of 21. Now, knowing price and quantity in this market, we can of course calculate consumer surplus, which equals 200. We can calculate the upstream profits, which equals 400. Downstream profits, Betrow paradox, 0 for either firm. And then the overall welfare in this market is 600. All right. We are now going to make some small adjustments to the model just to consider different scenarios and compare these scenarios against the benchmark situation which we analyzed under task A. So now in task B, we are going to assume that the upstream firm merges with both downstream firms. Both downstream firms, or both of these downstream firm divisions or parts of the now vertically integrated firm, will continue as separate business units. We will now assume that the internal wholesale price is equal to the marginal costs, which kind of probably makes sense on an intuitive level. It's one single integrated firm after all. And then we are asked to determine the price of the good in equilibrium and the service offered. We are furthermore asked to calculate profits, consumer surplus, welfare, and so on. And then finally, we are asked to answer the question whether or not the competition authority would or should allow this merger, this vertical integration of all firms in the market. All right, let's start. So, we are faced with a vertically integrated firm after this merger, right? So we have, after the merger, we have one single firm, and this one single firm wants to maximize the overall profits in the market. So this profit function of this vertically integrated firm, pi vi, then reads the price cost margin that is earned upstream multiplied with the quantity which results from the demand function that was given in this exercise minus the costs of investment into services. You can arrive this profit function, well, first by intuitively thinking what is now the price this integrated firm can achieve or gets from the market, what's the cost it has to pay, and what's the demand function it is faced with, and you will come to those results. Alternatively, you will come to the same profit function if you do what we usually do when we consider the profit function of a merged firm, which is calculate the sum of the individual firms that participate in the merger, of the profits of the individual firms that participate in the merger, right? So this result can also be derived by calculating pi vi equals to pi upstream plus pi downstream 1 plus pi downstream 2, right? By adding up all the profit functions of all the firms participating in this merger. Now that we have found and understood the profit function of this vertically integrated firm, let's find the market equilibrium by finding the profit maximum of this firm. This firm now has three strategic parameters it can choose in order to maximize its profits. The first one being the price it's asking on the market, and the second and third being the respective amounts of services that retail or downstream division 1 and downstream division 2, the two retailers, are now offering to the market. So we have a profit function that depends on these three strategic parameters. If we want to find the profit maximum, we need to calculate the first order conditions of this profit function with respect to each of these strategic parameters, which is done right here on the slide. If we do so, now we have three equations with three unknown parameters. We can make our life easier by knowing that this is a symmetric problem with regards to the amount of services provided. So we can immediately tell that E1 must equal E2 in this setting, which of course simplifies the equation system we have. And if we now solve this linear equation system for the parameters we have, we can find out that the price in equilibrium that this now vertically integrated firm will ask for is 41, and that the amount of services it will provide is 20 for each of both retailing divisions. So E1 equals E2 equals 20. All right, so with this we can of course calculate the quantity in the market that is sold, and with that then profits and consumer surplus, etc. That should be precisely what we are doing next. Right, so for given P, given EI, for given P and given E1 and E2, we can calculate the quantity in equilibrium. With this quantity in equilibrium, the prices in equilibrium, we can of course calculate consumer surplus and profits, and knowing profits or summing profits in consumer surplus, we can find out that the overall welfare in this situation is 1,600. So, towards the final question of this task, should the competition authority allow the merger? Well, in comparison to the benchmark situation where there was no integration of all firms, we see that both consumer surplus increases and overall welfare increases. So regardless on whether the competition authority chooses to follow a total welfare standard or a consumer surplus standard, it should in either case allow the merger. All right, and with that, we are done with this situation of perfect vertical integration and are now considering slightly more complex and more nuanced alternative situations. We will consider next a situation where instead of merging, all three companies enter into a vertical agreement. So there will be a contract that is slightly more complex than a full-blown vertical integration. This contract will take the form of a franchise agreement, which means there will be a two-part tariff. So as part of this two-part tariff, the producer sells a good at a wholesale price, which is, as part of the contract, fixed to W equal 1. The producer sells at a price of 1 to the retailers, which will then in turn pay a franchising fee that is to be defined or to be defined in the model. At the same time, the two retailers agree on exclusive sales territories, which means that each of the two retailers will act as a monopolist on their respective exclusive territory. Right, so monopolistically serves 50% of the consumers. And then we are of course asked to find the market equilibrium, calculate profits, calculate consumer surplus, and so on. All right, so in this setting, let's start by finding the market equilibrium. All right, so as always, we start with the downstream level in this market. Downstream, we have the following problem. We have a profit function that we already know, basically, because the profit function of each retailer, again, depends on the price it's asking from the consumers and the amount of services it is providing. And similar to what we earlier saw, we see that there is a margin. This margin then is sold on to some quantity Q, which we will talk about in a second. So we have a price cost margin, which is sold towards a quantity Q, and then the retailer incurs some costs of providing the profit maximizing amount of services, E. And now in addition, we have this fixed payment that was part of the franchise contract that for now is just simply treated as a parameter because we do not know what value it will take yet. Now towards this quantity each of the retailer is serving, well, we assumed in the exercise task in this text that each of the retailers downstream will be serving 50% of the demand as a monopolist. So what we can plug in here for the quantity that is sold is the demand function divided by 2. So we now basically have a monopolist that is facing half the demand that was given in the exercise text. Right, and with this profit function, we can now, of course, continue finding the profit maximizing strategy on the downstream level. As we have said, the downstream retailer maximizes their profit by choosing the two strategic parameters, price and services provided. So we have, in order to find the maximum, we will calculate as the first order condition of this maximum, these partial derivatives of the profit function. This, of course, yields two equations and two unknown parameters. Again, the usual way we find out our parameters by solving this linear equation system. If we do so, of course, we can make use again of the fact that the downstream firms are symmetric, so we can immediately simplify this equation system by considering that the equilibrium quantity of services will be the same for both firms, so EI equals EJ, and of course the same holds true for the end consumer price the firms are asking. If the firms are symmetric, of course, Pi equals Pj as well. Using this and solving this linear equation system, we find out that the profit maximizing amount of services provided by each retailer is 6 2/3. This amount of services then comes in equilibrium with a price of 27 2/3 and a total quantity sold in the market, which is 26 2/3. Now this is all we can do on the downstream level. Of course, we already know the wholesale price because it was fixed as part of the agreement, franchise agreement. However, what we still do not know is the profits of each of the firms involved, which then in turn depends on this amount of franchise-free T. So let's find out what happens on the upstream level, and in doing so find out how we can quantify this amount T, this this franchise fee T. So just as an aside, of course, knowing price and quantity in the market, we can immediately calculate consumer surplus already. That's just an aside. Let's continue as promised with the franchise fee T. So now the idea is that each downstream firm is willing to participate in this contract, to enter this contract, as long as it is making non-negative profits, right? Because as long as there is non-negative profits, it is a profit maximizing strategy to participate in this contract, right? The outside option would be to not be in the market and make zero profits. So as long as downstream is making non-negative profits, it should be at least indifferent between participating and not. By that logic, the upstream firm can set the franchising fee T at most at the level of the downstream profits, right? This franchise fee T can be chosen by the upstream firm so that the downstream firm is just barely not making negative profits. Or in essence, the upstream firm can use this franchise fee T in order to collect all the profits that were made downstream. As long as this participation constraint holds, and this participation constraint for downstream would be pi I, u, so the individual firm's profits downstream, so pi id, must be larger or equal than 0, right? That's the participation constraint. As long as that is given, downstream will agree to the contract. All right, so knowing this, considering this, the upstream firm can set the franchising fee exactly in the amount of the downstream profits. So T takes the value of the individual downstream firm's profits. We can, of course, calculate the downstream firm's profits because we know E, we know P, we know Q, we know the wholesale price the firm is paying, which is equal to the constant marginal cost of the producer by assumption. So we can calculate the profits firms are making downstream before paying the franchise fee, which is approximately 311.1. Right, this is the profits before paying the franchise fee T. So we know that the upstream firm can ask for exactly this amount T so that the downstream firm's profits are non-negative. All right. So bottom line is upstream firm extracts the profits of both downstream firms by choosing T profit maximizing, so as large as possible, while considering the participation constraints of the downstream firms. So T is as large as possible so that the downstream profits are non-negative. So with that we can calculate the upstream firm's profits, which is 2 times this franchise fee, once for each firm. So we have 2 times 311.1, which equals 622.2. And knowing the consumer surplus as well as the profits, we can then calculate welfare. Of course, by the whole argument we just made, pi I downstream equals 0 in equilibrium, right? So the welfare is technically, of course, the sum of all profits plus consumer surplus. But in this particular case, because downstream profits will be 0, we can calculate welfare as the sum of upstream firm profits plus consumer surplus. All right. Now, in order to explain the solutions, we made it on our way, I would argue, but just to summarize the explanation, what the differences we are observing between all 3 versions of this model so far is, well, we saw welfare is the highest under vertical integration, which came from the result that we perfectly internalized the spillover from services, right? Simply because both firms had exclusive territories and acted as a monopolist on their respective part of the demand function. So they they internalized all the spillover effects from investing into services. What we then saw is that even if we are not perfectly integrating, but rather constructing a franchise contract, that still results in a situation where we have exclusive sales territories. We still observe that there is services provided to some extent. It is, however, a reduced extent, but it's still not 0. Simply because in this case that we analyzed under task C, we have a non-perfect internalization of these spillover effects. Right. And of course, in the benchmark situation where there was benchmark competition, we had 0 internalization of the spillover effect that come from providing services E. Right, let's now consider a different version of this franchise contract and analyze what happens if we adjust this contract. We are now asked to consider a situation where the franchise agreement is as follows. The upstream monopolist binds the retailers to set retail price as at its optimal price under vertical integration. So what we are going to analyze here, of course, binding retailers to set some price. What we are going to analyze here is RPM, resale price maintenance. All right, so the producer is binding the retailers to some price they choose. In particular, it's not any price, but it's the price, the profit maximizing price we saw under vertical integration. And then we are going to assume that there is, in addition, a franchise fee T. There's still exclusive sales territories, and then we are going to analyze, based on this, what the equilibrium will be. All right, so, of course, if you remember the profit maximization problem downstream that we were analyzing over and over again, we always had the case that in the baseline situation, downstream firm chooses or maximizes their profit by choosing the amount of services and the price. Now, in this situation, of course, there is no price to be set because by assumption, retailers are bound to set this price that we saw under vertical integration, which was 41, right? So the downstream profit maximization problem, of course, then simplifies and reduces to a profit maximization according to the choice of the amount of services provided, because the price is fixed. All right. With that, we then have again a margin that is earned by the retailer. We have a quantity that results on the market for a given fixed price and for a given amounts of services provided. There's costs from providing services, and then there's a franchise fee T. And this profit now shall be maximized by choosing E1, so the amount of services, in the case of firm 1, and of course by choosing E2 in the case of firm 2. So if we do this, and let's just consider firm 1 for a second, of course by symmetry the exact same argument holds for firm 2 as well. So if we now find the profit maximum with respect to the choice of the amount of services, we find out that the amount of services is a function of the wholesale W, and this function reads 41 minus W divided by 4. So, yeah, right. Now, in order to find the equilibrium, we can take a shortcut at this point. A shortcut in the sense that, yeah, we can make use of a previous result, because if a firm if the downstream firms want to maximize their profits for a given price, so we know that in our price quantity diagram we have this decreasing demand function, and now we know that the price will be fixed to some 41 right here. Then we know that this price is profit maximizing only for the same quantity that we already saw under vertical integration. Because it's the same price that we saw under vertical integration, this price is profit maximizing only for the same quantity that we saw under vertical integration. Now, how do we reach this quantity that we saw under vertical integration? Well, by choosing parameter E, firms can choose, downstream firms can shift the demand function, right? So this, of course, is the demand function for some E1 and some E2, for some fixed E1 and E2. If they chose a lower amount or a lower quantity E1 and E2, they would have a downward shifted demand curve. And from this downward shifted demand curve, of course, results that for a given price, the sold quantity would be lower than the one we need in order to maximize profits. So this whole argument is just to support the idea that if we want to maximize profits for a given price, and thus we need to reach a given quantity under vertical, the same that we saw under vertical integration, where this price comes from as well, well then we need to shift the demand function in the exact same way that we did under vertical integration. Because only then, yeah, we have this exact same combination of price and quantity. For any other amount of E1 and E2, we have a different price-quantity combination. From this argument, it follows that the optimal amount of services provided is the same as under vertical integration. So we know that this term over here needs to equal 20, because that was the result under vertical integration. So we simply set it equal to 20, and we find out by doing so that the wholesale price must be negative 39, which is quite the interesting result, given there's also some marginal costs larger than 0. So basically what this says is Well, the upstream firm produces at a cost of 1 and sells the good at a negative 39, which basically means with every good they are selling, they just put on top of it 39 units of currency, which means they are basically incurring costs of 40 with every single unit they produce and sell to the retailer. Which on first sight might be counterintuitive. However, we must not forget that there's also a franchise fee in this model. And this franchise fee is exactly what helps us make sense of this result. Because for this given amount of, for this given wholesale price and the resulting, and this given price on the market and the resulting quantity the downstream firm is selling, downstream is making profits. And just as we saw earlier, the upstream firm can extract these profits from the downstream firm. Because, same argument as before, upstream is choosing the profit maximizing franchise fee T, so they are choosing T as large as possible under the constraint that the participation for downstream still makes sense, so meaning that the profit downstream must be non-negative. So the tariff, the franchise fee T, once again is set to equal the downstream firm's profits before paying the franchise fee. So that after paying the franchise fee T, downstream firm's profit equal exactly 0. And with this, well, now we can start to see how this makes sense while the upstream firm is asking for a negative wholesale price, thereby paying the downstream retailer for selling their product. At the same time, they are asking for this franchise fee T, right? And summing these two effects both up, we will see that upstream is making non-negative profits. All right, so in the result, we see that the overall profits in this market will be the overall profits in this market will be 800, which comes from the fact that the downstream firms will make profits of 1,200 each. Meanwhile, upstream will have profits of negative 1,600 before collecting the franchise fee. So after collecting the franchise fee, upstream is making a profit of 800. Downstream, of course, after paying the franchise fee, has 0 profits, which was the participation constraint. So what we see is that overall, the upstream firm's profits exactly equal the profits under vertical integration, which should not really surprise us, because we have the same market result that we had under vertical integration as well. We have the same price for the consumer, we have the same quantity sold on the market, we have the same amount of service provided. So the firm's profits should be the same, right? And because downstream is making 0 profits, upstream firm is making all the profits in the market, 800. At the same time, of course, we see the same consumer surplus as we saw under vertical integration. Again, we see the same market equilibrium as under vertical integration. So consumer surplus should be the same. It shouldn't be too surprising. And then, of course, the sum of both is the same as well, 1,600. Now one more version of this model. Let's now consider that the upstream firm can force the retailers to set the retail price under vertical integration, similar to what we just analyzed, but so far the same. At the same time, they are setting a minimum sales volume per retailer, and then we are asked to determine the price of the goods in equilibrium and the quality of service offered. All right, so previously, just as a reminder, previously we had exclusive sales territories which for both of the retailers. So each of the retailer acted as a monopolist on their respective 50% of the market. We now drop this exclusive sale territories and instead we consider a world in which firms are forced to sell a given quantity. All right, now what is the market equilibrium in this world? At first, downstream, the downstream profit maximization is not changed too much, because similar to what we just saw, the price is fixed at 41, so we already know that the profit maximization problem of the downstream firm is reduced. Moving from a benchmark situation where downstream maximized their profits by choosing price and service quantity E, downstream again can only choose service quantity E in order to maximize their profits. So this is the profit maximization problem, which is the same that we already knew from before, difference being there is no franchise fee anymore. All right, but it's other than that, it is the same profit function that we saw earlier. But now the downstream firm is choosing their profit maximizing amount of services provided E under a constraint. The constraint being that they must provide the same quantity they did under vertical integration, namely 20. So we have the constraint that the demand function must equal 20. So a profit maximization under a constraint, or a maximization under a constraint, that of course demands for a Lagrangian method. So we state the objective function, which is the profit function minus the constraint. Then in the next step we maximize this objective function with respect to the parameter of choice as well as the Lagrangian parameter, where at this point of course the partial derivative of this objective function with respect to the Lagrangian parameter exactly equals our constraint, equals 0 under the first order condition. And then second, we have the partial derivative of this objective function with respect to the profit maximization parameter E, the amount of services. Now we technically have this for both of the downstream firms. By symmetry, it's of course the same for both of the downstream firms, just with interchanged indices. And by symmetry of the firm, we also immediately may simplify our equations by introducing that the amount of services provided by firm 1 will be exactly equal to the amount of services provided by firm 2, because they are symmetric. So E1 equal E2. If we make use of all of this, so we have this, again, we have this equation, a linear equation system, and we have this symmetry which simplifies our equations, we can then solve this equation system and through this find out that the profit maximizing amount of services for a given amount of quantity that the firm needs to sell equals 20. Interestingly, we can see from this, we can see from the partial derivatives from the first order conditions of a profit maximum, we can see that the wholesale price does not affect the price, quantity or amount of services, which kind of makes sense because the price is fixed and the quantity is fixed, right? So for both of these, of course, by construction, wholesale price does not matter. Now, for the services, well, I could draw the exact same image I drew earlier, where we have this demand function that is shifted upwards or downwards by choosing E accordingly. And if we want to achieve in the market one specific price and quantity combination, that means we have to shift the demand function so that this combination is actually a point on the demand function, right? Which means that this given price quantity combination comes with or implies a certain amount of services provided. It implies that we are on this very exact same demand function, shifted to the exact same level, right? So once again, if we, by construction, fix the market price to the market price under vertical integration, and we fix the quantity in the market to the same quantity under vertical integration, then little surprisingly, we get the exact same rest of the market equilibrium as well, in the sense that the services are the exact same as they were under vertical integration as well.